We're now going to demonstrate the dynamic range and the linearity of the Voice200ultra. To do this, we have a sample with a trace level of 1,3-butadiene. Now this sample, as you can see, is in a 1 litre Tedlar bag that's connected to the inlet of the Voice200ultra. Now as we start analysing, we can see the concentration of 1,3-butadiene. I've just changed the measurement units here to parts per trillion, and you can see that the concentration of 1,3-butadiene in this sample is approximately 30 parts per trillion. We're integrating the signal for 5 seconds at each measurement point here, so you can see we're getting excellent measurement precision even at this very low level. Now I'm just adding acetone to the display also. Now acetone is also obviously being analysed by this method, and we can see the concentration of acetone in this sample is approximately 15 ppb. Okay, so about 500 times higher than the concentration of 1,3-butadiene. Now what we're going to do is inject a high concentration of acetone into this sample to show the effect that that has on the measurement of 1,3-butadiene. So Doug's just done that injection, and you see the instant response of acetone, the blue trace in our concentration chart here. The concentration of acetone has shot up to 30,000 ppb, or of course that's 30 parts per million. Okay, so we're just going to wait until that concentration settles, okay, once the sample equilibrates, and then we're going to switch the sample to another that contains the original concentrations of acetone and 1,3-butadiene. Okay, so we can see the concentration is quite stable now at about 30 to 31 parts per million. So Doug's now switching the sample across, and we see an immediate drop in the concentration of acetone. Now, you see on the interface here there's this overlay checkbox. If I uncheck this, 1,3-butadiene and acetone are displayed in separate windows, and we can see that the concentration of 1,3-butadiene has not changed as a result of this vast increase in acetone. So this is what we mean when we say that the SIFT-MS has a dynamic range that spans 6 orders of magnitude. In this case, we're measuring 1,3-butadiene at 30 parts per trillion, and at the same time in the same sample we're analysing acetone at 1,000,000 times that concentration, 30 parts per million. Furthermore, the fact that the 1,3-butadiene concentration doesn't change when the acetone concentration is raised from 15 ppb to 30 parts per million shows that we're still operating within the linear range of the instrument. Now we're going to do a final demonstration just to illustrate this linearity, because it's a very important and unique characteristic of SIFT-MS, that not only does it have this extraordinarily wide dynamic range of measurement, it also delivers a linear response over that range. So what we're going to do here is Doug has in a syringe taken 10 mils from that 30 part per million acetone sample, and he's going to inject that into this sample bag that contains 1 litre of sample. Okay, so 10 mils into 1 litre should give us a dilution factor of 100. So here goes Doug. Now note that I've changed the concentration scale here to a logarithmic scale, so we can very quickly see if we hit the mark we're shooting for. 100-fold dilution of 30 parts per million is 300 ppb, and once this concentration settles, if we count the decades, we can see that we are just about exactly at 300 ppb here. Okay, so if I just switch this back to linear scale, that just to emphasize that we've got 100-fold dilution here, and more interesting, if I add the 1,3-butadiene, we can see that the concentration of 1,3-butadiene has remained consistent at about 30 parts per trillion throughout the entire demonstration.